and now we're going to talk about the scientific revolution. As you can see, the scientific revolution took place between the 1500s and the 1700s. So keep in mind that you had absolutism going on, the Renaissance and the Reformation, lots of exploration, Mughal Empire, Ottoman Empire, all the things we've already talked about is going on during this time period too. So as people started doubting the church and doubting their leaders, they also started reaching for new knowledge. And that's kind of what the scientific revolution is about. It was a new way of thinking about the natural world, and it was based upon observation and a willingness to question accepted beliefs. It was started when a small group of scholars began to question what is known as the geocentric or earth-centered view of the universe theory. That was created by a man named Ptolemy, and he is the one that said that the earth was the center of the universe and everything revolved around us. And this group of scientists is going to get together and say, we don't think that's true. And once we realize we're not the center of the universe, it kind of humbles us and makes us look at ourselves a little bit differently. So now we're going to go to the next page here, and I'm going to start introducing you to some of the scientists that tried to prove Ptolemy wrong. The first man we need to talk about is Nicholas Copernicus. He was from Poland, and he was an astronomer. He's the first one that theorized that the sun stood at the center of the universe. This is called the heliocentric theory, and it laid the foundation for the entire scientific revolution. So he's the guy that's going to start it. Make sure you know that for your test. And just as a point of interest, you don't have to write this down, but just to kind of get to know what kind of person he was, astronomy was just really a hobby for him. So he's going to change the entire world because of a hobby. He was also an artist. He was a very well-respected military leader, a governor, an economist, a doctor. He just did a little bit of everything and had pretty much a degree in anything that you could think of. So he's a very intelligent man, and unknowingly, he's going to change the world. The next man that we need to talk about is Johann Kepler. Johann Kepler was a brilliant German mathematician, and he discovered something called the laws of planetary motion. Kepler's laws showed that Copernicus's heliocentric theory was true. That's the most important thing that you need to note, because now you have two very well-respected men that are saying, yes, this is true, the Earth is not the center of the universe. Further, Kepler went on to kind of study the movement of the planets and realized that they move in elliptical orbits rather than circles. And that is a huge part of his planetary motion theory. So I'm not going to get into tons of detail about his theory because it's very, very scientific and way over most of our heads. But just know that he did support the idea of Copernicus, and he also added to the fact that the planets move in an elliptical pattern rather than circles. Now we have Galileo. Galileo did not invent the telescope, but he definitely perfected it. And he used that perfect new instrument to back up the idea of the heliocentric theory in 1609. He made astonishing observations that supported this theory, and now he has a tool to help prove it. The problem is Galileo is an Italian. And being an Italian, everybody knows that the center of the Catholic Church is in Rome, in Italy. And so people in that time period were still very stoic, very attached to the old ideas of how humans are more important than anything else, and we are the center of the universe as humans. And they didn't want to hear the idea of the heliocentric theory where Earth was not the center of the universe. And so he was denounced as a heretic, and he was given a choice by the church to either go under house arrest for the rest of his life and recant, say that he had lied, that none of this was true about the heliocentric theory, or he could in fact drink poison hemlock, like had been done since the ancient Greek times, and kill himself. And so he opted to spend the rest of his life under house arrest, and he did recant. He said that he lied. So it's just that it was so much more strict in Rome in Italy itself because of the Catholic Church. I do want you to know a couple other little things about him just to show you how smart he was. He is the first guy ever to figure out the path of cannonballs upon firing, and the fact that weight does not affect the velocity of a falling body. He could actually figure out exactly where to aim a cannonball and how to aim it to make it hit a small target. And that is no small feat. So you're talking about a guy who was a mathematical genius, and using his mathematical genius, he looked into the heavens with his new tool and said, we are not the center of the universe, and then had to completely back down because of the church. Lucky for us and for science, there were so many others around at the time that were willing to support the theory of the heliocentric theory, that it's not going to disappear forever. Just to give you an idea of what the telescope did for science, and why it's not going to die, because even though Galileo had to recant, his telescope's out there and people are going to use it. But this picture that you see in front of you, my husband and I actually took, well, my husband did it, I got to give him credit for it. We took it on top of a mountaintop during a very beautiful, clear summer night. And he did it with just a little simple camera, definitely not his professional camera, is just a little simple one. And if you look at the center of the screen, what do you see there? It's a galaxy. So if you can see that with a little tiny camera that was nowhere near as strong as Galileo's telescope was, just imagine what Galileo could see through the instrument that he perfected. So there you go, and shout out to my husband for being such a great photographer. Now, all of this became the way of the world, and this new method of looking at the world was developed, and it's called the scientific method. So the scientific thinking of all of these guys, Copernicus, Kepler, and Galileo, are the ones who eventually developed this scientific method, and it's a logical procedure for gathering and testing ideas that's based on nothing more than observation and experimentation. So you can see the very first step is to observe whatever question that you have. You have to observe things and develop a question. Then you would form a hypothesis or an educated guess using mostly other people's information, maybe a study that has already been done on it, and then you would do your experiment. And based on the results, you would either support your hypothesis or say my hypothesis was wrong and start all over again. But most of it is just purely observation, looking at the heavens, mathematically calculating the movement of the planets, that kind of thing. But it started with observation and realizing that things were actually moving in space. That's what this whole thing was about. And we have Isaac Newton. Newton is the guy who came up with the laws of universal gravitation. And these laws say that the same force controlled the motions of all matter, both in Earth and in space. And according to this law, every object in the universe attracts every other object. The reason that we stay on this planet, even though everything around us, and us included, has an attraction to each other, the reason we stay on the planet is because you are more attracted to something with a larger mass. And what has a larger mass than the Earth itself? So if I drop a pencil, it's not going to fall up, it's going to fall towards the thing that has the most magnetic attraction, or the thing with the largest amount of mass, and that would be the Earth. That keeps us from bumping into each other due to the magnetic attraction. That keeps us from flying, basically, is what it does. So he's the guy that came up with universal gravitation. He's also the one that was the first to realize that prisms show up in sunlight, and these prisms are all the colors of the rainbow. So he's the guy that gave us that. Again, you don't need to know that. I just want you to know the laws of universal gravitation. But none of this was happening in a vacuum. These ideas about heavenly bodies and how they move and why we stay on this planet, all these men were making all kinds of discoveries. Science was on fire during this time period. If you can doubt your church and you can doubt your leaders, you can definitely doubt the world around you. And that's what the scientific revolution was all about. Then we're going to get into a little bit more of the study of a human being, and we're going to do that with William Harvey. William Harvey was from England, so again we have another country involved in this, and he's the one that discovered the circulation of blood. In 1628, he proved that the heart acted as a pump to circulate blood throughout the body, and he actually did this using cadavers and forcing blood through their veins and arteries, and creating this pump action. And then he led himself back to the heart by following the veins and arteries in a dead body, and realized that everything centered from the heart out. He also, believe it or not, argued that mammals reproduce through the joining of a sperm and an egg. 200 years before that was actually proven, and he was kind of laughed at for that. But he realized there was something more about reproduction than what we understood. So he was looking into that too. But the big thing I want you to know about him was the circulation of the blood. Edward Jenner was also a scientist. He was also from England, and he's the one that discovered a vaccine to prevent smallpox in 1796. And you can see from this picture here, as disgusting as it is, smallpox could do very, very bad things to people. Of course, that's one of the major diseases that wiped out the Native Americans when the Europeans first settled over here. But even for Europeans who were used to this disease, it can be deadly. Even if it's not, it definitely scars you for life. George Washington, our first president, had smallpox as a young man, and he was not an attractive guy after that. He had a lot of very deep facial scars that embarrassed him for the rest of his life, and supposedly that also made him sterile. That's why he and Martha never had children. Now, Edward Jenner supposedly found a cow that was infected with the disease, and he took pus from one of the sores and injected it into children, believe it or not, and realized that by injecting it, your body could be kind of tricked into believing it already had the disease. So once the kids were infected with the vaccination, he would actually take them to visit people that were infected with smallpox to see if any of them got the disease, and none of them did. Lucky for him, right? He didn't kill off all the children in his neighborhood. If you sum it all up, the importance of the scientific revolution, it's mind-boggling. So we're just going to kind of cut it down to a few things here. For one thing, it gave us that emphasis on reason. Observing and then using reason and logic to figure out what we just saw. Sounds simple, but it wasn't. It was a brand new thing. And that leads us to the use of the scientific method. Another big thing. So observation, reason, use of the scientific method, and both of these things kind of exploded into an expansion of scientific knowledge in medicine, in space, in all kinds of things. And that is the end of the unit for the scientific revolution. Short and sweet.